guys, welcome back to my channel. Today we're gonna discuss the C problem annoying game from Codeforces round 1067. I planned to actually bring this uh, like 2 days back, but due to some reasons I couldn't do it. But yeah, let's do it today. So the problem says you're given two integer arrays a and b, both of length n, and a total number of turns k. Alice and Bob play a game by taking turns modifying array a. Alice goes first. The game lasts for exactly k turns. On their turn, a player must choose an index I and perform one of the following operations. Increase ai by bi, that is set ai equals to ai plus bi, and or subtract, so ai equals to ai minus bi. After the kth turn is complete, the final score is calculated as the maximum non-empty subarray sum of the modified array a. Ali's goal is to maximize the final score while Bob's goal is to minimize the final score. Assuming both players play optimally to achieve their respective goals, determine the final score, right? So what this problem says is, let me try to break it down for you. This problem was actually easier than the B one, if you think of it like this. So basically we're been given an array like 1 2 3 minus 10 4 5. So let's say this is an array a. Okay, now what this says is we have a integer k. Okay, so this is the number of operations or the total number of times the Alice and Bob play this game, where in each turn they could either add bi to ai or subtract bi from ai, right? So these are the two operations that they could perform. So they could perform either one of them, right? Okay, so they are saying the goal of Alice is to maximize the final score, and the goal of Bob is to minimize the final score. So we can see that to maximize the final score, we are gonna add this number, right? Because minimizing would never actually increase the score, right? Because if we are subtracting even, let's say, some small number 1, this makes it 2, right? So this element decreases, so subtracting would never actually increase the maximum subarray sum, right? So Alice will always perform this add operation, while Bob's goal is to minimize the final answer, right? So Bob will always perform a negative operation, or Bob will actually perform always perform a subtraction, right? So that is what I'm saying. These operations are specific to Alice and Bob, right? And we have been given an array k, right? And these are the number of turns the game has been played. So let's say k is equals to 5. So first Alice plays. This is actually given in the problem that Alice goes first, right? So first Alice plays, then Bob, Alice, Bob, and then Alice again. Okay, so we have been also given an array something like b. So this is let's say something like this. Okay, so what we can see or what the question is saying is, the Alice could basically, from what we understand, Alice will always add the answer, right? So Alice could choose any index I, right? So if he chooses this, then he could add this bi to this ai, right? And similarly for Bob as well, he could pick any index. Let's say he picks this one, and then he could subtract this from this, right? So what we want to do in this problem is, we need to find the maximum non-empty subarray sum, right? So you might have heard of the Cadence algorithm. We actually need to find what is the maximum subarray sum, right? Because it is given in the problem, the final score is calculated as the maximum non-empty subarray sum. So this is nothing but Cadence algorithm, if you think about it like this. The prerequisite obviously for solving this problem is Cadence algorithm. You should know about how Cadence algorithm works, right? So basically Cadence algorithm always gives us the maximum subarray sum of the entire array, right? So I think in this array it would be 5 plus 4 9, and then this would be it. So in this array the final answer would be this 5 plus 4, this, which is 9, right? Now let me make a claim. So if we have been given something like two operations, right, and Alice is going first, so Alice will always add a bi to an ai, right? So if we think greedily, can we determine that we could pick or Alice would pick the greatest or the or the bi such that the subarray sum is maximized. So for example, Alice is picking this one, right, and he is adding this to ai, and then this becomes 6, right? So 5 becomes 6 now. So now this subarray sum becomes 10. So I could claim that Alice would or Alice will always pick such an element that would maximize the final subarray sum, right? So that is what I'm claiming, and that will always be true, right? Alice will greedily pick such an element which maximizes the overall or maximizes the subarray sum, right? So from that we can determine when it's Bob's turn. So Alice has, let's say, taken this element 1 and then added this to ai. So now this becomes 6, right? And if it's Bob's turn now, wouldn't Bob will try to make this again 5 or revert this operation which was performed by Alice. So my claim is Alice will always add an element which maximizes some or which maximizes some subarray sum. So there would be some subarray which sum gets maximized, right? So for example, Alice would think that we should pick this element because this maximizes the result. 5 becomes 6 and the overall subarray sum becomes 10, which is the maximum possible, obviously, right? So he would pick this element and then add this to this. And when it's Bob's turn, now the Bob will think that he need to minimize the total subarray sum, right? In order to minimize this, so if it's Bob's turn, don't you guys agree that Alice would have already performed a maximum subarray sum operation, right? Or the Alice would have already added a element such that the subarray sum is maximized. We claim this here, right? So if it's Bob's turn, so Bob will always play after Alice. Okay, so when Bob will play, Alice would have already maximized some subarray sum, right? So he maximized the subarray sum right here. So the best option for Bob is to revert this operation. I can claim that the best way for Bob is to just revert this operation, right? I'll just take a sample case, and then I think it would be much more clearer. So yeah, this is a good case. So 10 10 10 10. This is 1 1 1 1 1 1. So if k equals to 2, that is we have two rounds. Alice goes first. So all elements are equal. We couldn't. Alice would take just, let's say, this one. Add that to ai. This is ai. This is a. This is array b, right? So basically now our subarray sum has become 41. Okay. Now what Bob would basically do, that Bob would think or Bob would see that before Bob's turn, Alice would have already just increased the maximum subarray sum. So in order for Bob to minimize the subarray sum, he needs to revert this operation. So he would want to convert this 11 to 10 again by subtracting this ai, right? So by subtracting this one, so Bob will want to actually convert this back to 10, and now our subarray or our array is just the same again. I want to think about it for a little while, right? so that it would be much easier to digest. Because I'm saying if Alice maximizes, if Alice let me just write it, if Alice maximizes uh, some somewhere sum, then the best option for Bob is to just revert that operation. I'll take a sample case so that it is much more clearer. So we can just pick this one and modify this a little bit. 1 2 3 minus 10, this is 1 2 3 minus 10, and this was 4 and 5, I guess, right? And I might just take some random integers here. I'll take a minus 100 over here, okay? And then we could have a 0 and a 1 here. So let's say we have k equals to 2. Our maximum subarray before performing any operation is 9, if you guys agree, right? So this is the maximum subarray sum. Now it's Ali's turn. So if Alice has to do something, he would just pick this one, add this to 5, and now this becomes 6. Okay. So now the subarray sum is 10. Now it's Bob's turn again. So now Bob could potentially take this largest bi and add this to this minus 10. So this would eventually become minus 110, right? If he picks bi greedily, you might consider that Bob will want to consider the maximum or the minimum bi element. But as you can see here, the minimum bi element would change this, but it will have no effect on the maximum subarray sum. See, the maximum subarray sum is still 10. It was 10 before and it is still 10. So it doesn't make sense for Bob to choose the minimum bi, right? It doesn't make any sense, because the subarray sum remains as it is. If this bi would have been inside this subarray, then then Alice would have taken it in order to maximize that, right? But Alice didn't. So I'm claiming that whatever Alice performs, Alice will always try to maximize the subarray sum. So Bob will just revert that operation. Bob will not do any Bob will not pick any bi, that is least bi, or which is the minimum possible. He will just revert this operation back to 5, and our array becomes back to its original form, right? So now essentially I could just check if k is a multiple of 2, or if k mod 2 is equals to 0. That means Alice plays once, and then Bob plays, and then Alice plays, and then Bob plays, right? So this is basically just two of them playing together. So Alice makes some move, then Bob neutralizes that. Alice makes some move, Bob neutralizes that. So our array doesn't essentially change anything. So this array remains same, right? So in that case we can consider, we can just use Cardan's algorithm, and we can just think what is the maximum subarray sum by using normal Cardan's algorithm, right? So this is 9 in this case. Okay, so the second case we have is if k mod 2 is actually 1. So if k mod 2 is 1, that means that let's say Alice makes a move, and then Bob makes a move, and then Alice makes a move again. So let's say this is an example for k equals to 3. Okay, now let me just take the same example again. So this is 1 2 3 minus 10 4 5, and this is what 1 0 1 minus 100 0 and 1. So essentially what I'm saying is Alice makes some move, then Bob cancel it, then Alice makes some move again. That means Alice have an edge. Alice could add any element to AI, and then that would be actually taken into account, because Bob doesn't have any more moves left to neutralize this operation, right? Because Alice makes the last move if k is odd. So now Alice has an edge over Bob, and he can actually try to maximize this score. Now the question comes is, how do we maximize this score, right? So if you think about this problem carefully, if we have some x in the array, and this is the left part of the array, and this is the right part of the array. So if we think carefully, then you would actually see that this x forms a maximum subarray sum. There would be three cases. Either this x comes in the left subarray or left maximum subarray, or this x comes in right subarray, or this x comes in itself. So if I don't know actually how to just explain that to you, but if we have, let's say, some elements 1 2 3, then minus 10, minus 15, and say 40, then 10 maybe, and then minus 100. So we have something like this, and x equals to 40. So what I'm saying is, if we need to find the maximum subarray sum, or if we are at 40 and let's say we need to find maximum subarray sum, which includes 40, okay. So if we need to find the maximum subarray sum which includes 40, what are some of the possibilities that would consider this 40? So we could either start some subarray from this 40 and go to right, or we could start some subarray from 40 and go to left, right? Or we could start some subarrays from 40 and then stay to it, or stay at it. I'm sorry, pardon my English. So there are essentially three cases. We could start from 40 and then we can move to the right. We could start from 40 or then we can move to the left, or we could just stay at 40 itself. In this case particularly, we would start from 40 and move to 10, because this gives us 50. This is the maximum possible, right? We will not move to the left, we will not move to the right, or we will we will not move to the left, or we will not just stay at the 40, we'll move to the right, and then we'll have a 50 here, right? So essentially that is what I'm saying. For every element ai, it either comes in the left subarray, or either in the right subarray, or in just itself. So those are only those three conditions are the only conditions that I need to handle. We do not need to handle anything else. If I have some subarray, don't you guys agree that we okay, yeah, there is one more case. Yeah, I'm sorry, I forgot about it. So there could also be something like that. Say this is 50, 40, and then 10. So if I'm standing at this 40, then we might also want to consider sometimes this whole complete subarray from left to right. So we start from here and go to the left as well, as go to the right as well. So we take this whole complete thing, right? So this is one other option. So we have four different types of cases. Either we take this alone, we expand and go to the right, we expand and go to the left, or we expand from both the sides, right? So essentially, if we want to begin from this element and go to the left, then don't you guys agree that from here, or let's say if we want to start from 40 and go to the left side, we will only take this if, let's say, our subarray sum till here is like something or let me put it this way. Let me say it. We could have a prefix array and a suffix array, and then prefix array would prefix of I would actually give the maximum subarray sum ending at I. So the prefix of we could have two arrays, and then the prefix of I would store the maximum subarray sum ending at I. So let's say this is 1 here, prefix of I, then we could expand this array which we started from 1, so prefix of 1 would be 3, 1 plus 2 is 3. Now similarly we can add this 3 to our array subarray as well. This is the subarray, so prefix of 2 or pref of 2 would be 6. In this case we add this thing, and similarly when we encounter this, the overall actually decreases. So I think it would be 6 minus 4, this would be minus 4 for this, Similarly, this would be minus 4, minus 15, minimum or maximum of minus 19 and minus 15. So, so this would be minus 15 itself, because if we take this part, then it actually minimizes the answer further or brings the answer down. So we will not take this one. We'll take the maximum, which is 15 in this case. So this remains 15. Now, if we when we encounter this element, then we take minus 15 plus 40 or just 40. So minus 15 plus 40 is 35, or no, sorry, 25 or 40, which is 40 is maximum. So we'll take 40. So what I'm saying is, just to let you guys know, prefix of I would be equals to max of ai, or prefix of I minus 1 plus ai. So there are basically two options that I have when I stand on this index. I could either continue on the left on the left subarray which we were continuing, or I could start a new subarray from here, whichever is the maximum. I'll do that greedily, right? Because this is a subarray, right? So when I stand at this index, I have two options. Either I could just expand this previous subarray, or I could begin a new one from here. So that is what I essentially wrote here. I could start a new subarray from here, or I could just take the previous one, right? So prefix of I would give that, and suffix of I similarly would give maximum of a of I, and then suffix of I plus 1 plus ai. So prefix of I indicated the maximum subarray sum ending at I, but suffix of I would give the maximum subarray sum starting from I. So let's say suffix of I is 10 here, then it gets to 50 here, because 40 and then 40 plus 10, 50 is maximum. So this becomes 50 here, right? And then this becomes 50, 15, which is what, 35. So this becomes 35 here. So I'm essentially saying suffix of I, suffix of I would be the maximum subarray sum, the same thing, starting from I. Right. So now if we come back to the problem again, now if we get the suffix of I of 40, then wouldn't we get maximum subarray sum starting from this? That is, we'll go from here to right side. And then if we get the prefix of I, wouldn't we get the maximum subarray sum ending at this 40, right? And then I could just take the maximum of those, right? So basically what I'm saying is, I could either take or I could just take, or let's say I have divided this into 4 cases, right? The first one is just take ai, second one is expand to right, third one is just expand to left, and the fourth one is expand to both left and right, to both, right? So to check these 4 conditions, what I essentially could do is, when I do this suffix of I, so let me just write down these indices: 0, 1, 2, 3, 4, 5, 6, this is 7. So when I write this or when I get this suffix of 5, this will, we just wrote that it will give me the maximum subarray starting from this 5. So that would mean it would give the maximum subarray to the right of this. Similarly, when I get the prefix of 5, it will actually give me the maximum subarray ending at 5. So this will give me the left subarray, right? So now we can just handle these 4 cases, and then we could add bi to it and take the maximum. So this was ai, right? So this was an array A, and now let me show you guys the code, then it will be much more easier, right? We are actually just brute forcing on bi, and we are actually trying all the possible combinations of bi. So let's say if I take this ai, then what is the answer giving us all for all the 4 cases. We'll just take the maximum out of them. So let's say if I'm adding this bi to or I'll just get a the maximum out of suffix of I or prefix of I. So this is essentially 0 1 2 3 4 5. So I'll get the maximum of suffix of I and prefix of I. So this side and this side, and then I'll just add a bi to it. So because Alice is essentially adding this bi to this, right? So we'll add this bi to this, and then this will handle these 2 cases. And for the other 2 cases, we could just add a bi to this ai to handle this element alone. Or at the for the 4th cases where we're taking this complete part, we could just take I'm just writing p of I for prefix of I plus suffix of I, and this element gets included twice because prefix of I is giving the maximum subarray ending at I, and this is giving the maximum subarray starting from I. So this is essentially giving 2I, which is 1I. The current element is coming twice, so we'll just subtract one ai to it, ai from it, and then we'll add a bi to it because this bi is getting added to this one if Alice perform this operation. So we'll just take the maximum for all such cases. We'll take the maximum of this ai plus bi to handle this element alone, for this element alone. Third case is suffix of I plus bi. So this gives me the right part, and then prefix of I plus bi. So this gives me the left part, this one. And we could just take the maximum of all 4 cases. That's it. So I'll show you guys the code. This is the code. We're taking the a and b arrays input. I'm initializing the prefix and suffix arrays in minus infinity or long int or long minimum, sorry. And then I'm taking I'm just constructing this prefix and suffix array. If k is mod 2, this actually means k mod 2 is actually 1. So I'll return this mx2, which I'm maintaining here. This is after when Alice have one chance remaining, or if Alice doesn't have any chance remaining. So I'm just maintaining a global maximum subarray so I'll just return that from if that's the case, right? So I'm taking all the possible combinations right here. So this is prefix plus bi, this is suffix plus bi, this is nothing but right and left subarray. Then I take the current element itself, and then I take both the left and right. So these are just the 4 conditions that needs to be handled, and that's pretty much it for this problem. The main part was actually seeing that the current element, suppose this is an element x, this is some left subarray, this is some right subarray. The main part was seeing that this element could actually belong either to this one or to this one or to the right one or to both ones, or this is an element in just itself. Whichever gives us the maximum answer, we'll try brute forcing all the values. So this the time complexity is nothing but order of n. We're checking for all the possible bi. We're adding all the possible bi for all I from 1 to n. So this will give us the global maximum answer, and that's it. I hope you guys understood what I was trying to say. But if you have any doubt, let me know. Thank you.